Welcome to this tutorial, Valve and Actuator Selection in HIT Portal. This example is for a heating plant with pressurized distribution with 2-port kVS valves. Here is the plant situation. In this plant, the main pump at the producer ensures that the water is circulated across the producer and the main pipes up to the bypass of the injection circuit and back. Both consumers' heating groups 1 and 2 are set up with an injection circuit with 2-port valves. They must get the required water flow with their respective pumps from the bypass, circulated across the consumer and bring it back to the bypass. Heating group 1 supplies an air handling unit which is located about 30 meters away from the heating plant room, respectively the main distributor. The injection circuit is set up at the air handling unit itself. Heating group 2 supplies a floor heating system of the building and the injection circuit is built up directly on the main distributor. The control valve and the corresponding actuator for heating group 1 can very easily be selected in the Siemens HIT Portal. Click on Product Selection. Then, Valves and Actuators. Now you can choose whether you want to select the valve based on the present application, or whether you prefer to go to Direct Valve Selection. We choose Valve Selection based on application. Select Heating Groups. Now you arrive on the selection page for valves that are suitable for heating consumer groups. The selection has already been restricted based on the application. Click on Calculation to correctly select the control valve based on the plant data. First, select the type of hydronic circuit. Select Injection circuit with 2-port valve for the pressurized distribution with variable volumetric flow. Now, a small graphic of the hydronic circuit is displayed with its most important information. Click on Use Selected Circuit. This limits the list of possible control valves in the background to 2-port valves that are suitable for the circuit you have selected. Now, the volumetric flow that the valve must handle must be calculated. Click on the calculator symbol to enter the detail information. The volumetric flow is calculated using the power formula from the rated capacity and the applicable temperature difference. In this calculation, typical constant values for density ρ and specific heat capacity C are used. Here once again the plant schematic with the data for the heating group 1. The rated capacity of 55 kilowatts can be entered directly. Now it needs to be considered which temperature difference is applicable for the valve selection. The control valve operates with the generator supply temperature of 50 degrees, and the return flow temperature from the heating group of 40 degrees. Therefore the applicable temperature difference for the valve selection is 10 Kelvin. Click OK. The volumetric flow has been calculated at 4.73 cubic meters per hour. Now it needs to be considered which resistance, delta PV100, the control valve must bring into the plant to achieve good controllability. Click on the calculator symbol to enter the required detail information. We have received a target value of 20 kPa for delta PVR from the consultant. Delta PVR is the pressure difference between the main supply and return line that the pump must provide at this point in the piping system. We enter 20 kPa for delta PVR according to the target provided by the consultant. The calculation works by default with a valve authority PV of 0.5. Based on that, a pressure difference delta PMV of 10 kPa results. The valve authority PV is the ratio of delta PV100 to delta PVR, or the ratio of delta PV100 to delta PV100 plus delta PMV respectively. With delta PV100 being the pressure drop across the fully opened valve at volumetric flow and delta PMV being the pressure drop in the piping section with variable flow. Which part of the piping system the variable flow section is, depends on the hydronic circuit. In the shown plant graphic of the previously selected injection circuit with 2-port valve, the variable flow section is highlighted accordingly. It is the piping section in which the water flow changes when the control valve changes its position. A valve authority PV of 0.5 means the pressure drop across the valve, delta PV 100, is half of delta PVR, or in other terms, it is equal to the pressure drop in the variable flow section delta PMV. For the example, this means that a pressure drop across the valve of 10 kPa is aimed for. Note that additional components, such as heat meters installed in this piping section, must also be considered in the value of delta PVR. Such components often have high resistance values, which significantly affect the size of the valve. Click OK to take the entries over into the calculation. Based on the volumetric flow and the desired pressure difference across the valve, delta PV 100, the calculated nominal flow kV is determined. This means the desired or ideal size or the ideal kVS value of the valve. The kV value, and also the kVS values, are standardized flow values at a pressure difference across the valve of 100 kPa, or 1 bar. Click Accept. By doing so, the calculations are being finalized and the selection of applicable control valves will be further limited based on that. This select list can be further reduced. For that, select the desired or required valve parameters such as ports, connection and valve type. The selection is now limited to 3 applicable valves, and the order of this list is according to the previously selected application. In order to select a suitable valve, some additional information must be taken into account. These can be found, for example, in the data sheet or in the product brochure. The valve type VVG44 operates with a stroke of 5.5 mm and a linear characteristic. The valve type VVG41 offers a stroke of 20 mm and an equal percentage characteristic. The valve type VVP45 operates with a stroke of 5.5 mm and also has a linear characteristic in this size. We select the valve VVG41.32 because with its equal percentage characteristic it fits nicely to the transfer behavior of a reheating coil in an air handling unit. As you can see, these valves now provide an effective resistance delta PV 100 of 8.74 kPa, resulting in a valve authority PV of 0.47. This is acceptable for the present application. If you select the pencil symbol, you can choose a different size, that means a different kVS value, if required. In this list you can see the effective resistance delta PV 100, and the associated valve authority PV a different valve size would have. In our example, the next smaller size with kVS equal to 10 cubic meters per hour, would already have a much greater resistance, and thus an even greater valve authority. We therefore accept the proposed size with a kVS of 16 cubic meters per hour. Now, select the appropriate actuator for this valve. Here, a select list of suitable actuators is also provided. Now the desired parameters for the actuator must be provided. It should be noted that this control valve is located at the air handling unit and is controlled by the ventilation control. Positioning signal, 0 to 10 volts. Operating voltage, 24 volts. Positioning time, medium, that means 30 seconds. And so on. We select the actuator SAX 61.03 and the valve and actuator selection is completed. This selection of valve and actuator can now be added to the cart. Or, if there are many valves to be selected, this selection can be added to a project. For heating group 2 the approach is similar to heating group 1. Special consideration must be taken with the fixed premixing. The heating consumer requires a supply temperature of 35 degrees. The boiler provides a supply temperature of 50 degrees. And the return temperature from the consumer is 28 degrees. Therefore the applicable temperature difference for the control valve is 22 Kelvin. For the calculation of the volumetric flow, the rated capacity of 60 kilowatts can be entered directly. The applicable temperature difference of 22 Kelvin can also be entered. Click OK. The volumetric flow has been calculated at 2.35 cubic meters per hour. Now it needs to be considered which resistance, delta PV100, the control valve must bring into the plant to achieve good controllability. Click on the calculator symbol to enter the required detail information. The desired resistance of the valve delta PV100 for heating group 2 must be determined considering the necessary pump pressure for the heating group 1. For heating group 1, delta PVR resulted in 18.7 kPa with the selected valve. This means that the main pump presses the water from this point also into the heating group 2 with the same pressure. The value for delta PVR of 18.7 kPa can be entered directly. A delta PMV of 9.35 kPa is now displayed at a valve authority PV of 0.5. However, the resistance in the variable flow section delta PMV, in heating group 2 is lower. This is because the pipes are short and have a lower resistance up to the bypass of the injection circuit. Only the balancing valve for hydronic balancing introduces some resistance. For the shown situation, delta PMV is therefore 5 kPa. To achieve a delta PMV of 5 kPa in the calculation, we now select a valve authority PV of 0.75. This results in a delta PMV of 4.68 kPa, approximately 5 kPa. The difference to the 18.7 kPa with which the pump presses must be provided by the control valve in heating group 2. This results in a desired valve resistance delta PV100 of 13.7 kPa. Click OK. Based on the volumetric flow and the desired pressure difference across the valve, delta PV100, the calculated nominal flow kV is determined. This means the desired or ideal size or the ideal kVS value of the valve. The kV value, and also the kVS values, are standardized flow values at a pressure difference across the valve of 100 kPa or 1 bar. Click Accept. By doing so, the calculations are being finalized and the selection of applicable control valves will be further limited based on that. The selection is now limited to 3 suitable valves. Here we select a type VVG44 with linear characteristic, with a nominal diameter of 20 and a kVS value of 6.3 cubic meters per hour. This valve type fits nicely to a heating group with supply temperature control. The effective pressure drop across the valve, delta PV100, is 13.86 kPa, resulting in an effective valve authority PV of almost 0.75, with delta PMV equal to 5 kPa. Additionally, the actuator is being selected with suitable parameters for heating group 2. Now the control valve and the actuator for heating group 2 are selected. They can also be added to the cart or a project. In summary, here once again the most important aspects to be considered when selecting a valve. Which hydronic circuits are used, and what are the consumer's performance data? Pay attention to the correct temperature difference for the volumetric flow determination, that means: what temperature does the generator supply? What return temperature comes from the consumer? Consider delta PVR as specified by the system builder or the consultant. This delta PVR must be provided by the main supply pump. The valve authority PV should be equal to or greater than 0.5, or in other words, delta PV100 should be equal to or greater than 0.5 times delta PVR, for the consumer group with the largest delta PMV. Delta PVR applies to all consumer groups supplied in parallel. This means that the control valve in a consumer group N with its delta PV100 should bring the difference between delta PVR and delta PMV of this consumer group N into the plant. In summary, here the selected valves and actuators for the heating groups 1 and 2. Thank you very much for your attention.